Welcome back. Today we're going to talk about circles and ellipses. The cool part about circles and ellipses is they're very closely related. Let's look at the equation for a circle. We're going to generalize it here. With the equation for a circle, you're probably familiar with this one. X squared plus y squared equals r squared. But also, as we've kind of talked about here in the last couple of videos in these sections, is we've got to be able to generalize for moving around that vertex on a parabola or the center on a circle. So for example, this would be HK is the center. And if you look up here, you know, x squared plus y squared equals r squared, well, that would mean that h and k are 0. So this is a circle centered at 0, 0. And then this would be if it was moved. An ellipse. I'm actually going to draw a picture of this first for you so that we can kind of see how it works. And then I think that's really going to help us as we lay out exactly what is an ellipse and what are its attributes. So I'm going to do my best ellipse. That's not too bad. And so when we look at an ellipse, a couple of important things pop out here. An ellipse also has a center. And kind of like we were talking about with a parabola, it has a focus, but it actually has two. And so these foci are actually very closely related like this. There's a distance. I'm drawing a second one down here. I'm going to come back to that drawing up there. But let's say I've got these foci here, right? There's a distance that exists from a focus to the outside of the ellipse and then to the other one. So it forms this kind of triangle. We'll call this D1 and D2. And there's a bunch of these different ones. So I could also draw this one. Check this out. So here's D1, here's D2, like this one here. This would be D1, this would be D2. And the cool part about it is when you draw an ellipse, these two distances, D1 plus D2 is always the same. And that's what gives the ellipse this shape is that there's a distance from the focus to the outside on each one of them, and that distance, when you add both of them together, they move around like they shrink and expand. So D1 could be shorter, could be longer, but the sum of them is always the same. As we look at this ellipse up here that I drew, a couple of distances become very important. There's a distance here from the center to the focus. That's distance C. C is the center to the focus. There's a distance, and I'm going to label it in blue here. It's B. It's the center to the outside on the minor axis. Well, how do you know if it's the minor axis? It's the smaller one, right? So there's this major axis here, and this is going to be the major. This is the major axis. Along the major axis fall the vertices. So that should be a vertex. This would be a vertex. And those are on the major axis, the long axis of the ellipse. And that distance from the vertex to the center, and here, these are, this is distance A, right? That's distance A. So A is from the center to the vertex on major axis. And I'm actually putting that in parentheses because by definition the vertex is on the major axis, and those are the important points. The major axis can also be called the focal axis. Okay, so this can be called the focal axis also because it's got the foci on it. Okay. What's the equation for an ellipse? The equation for an ellipse looks like this. X squared over a squared plus y squared over b squared is equal to 1. Always has to be equal to 1. Okay, so we're going to see here in a few minutes when we do an example, there's going to be one that's not equal to 1. Well, it's got to be equal to 1. Okay, got to be equal to 1. Let's look at the equations here. 4 standard equations. I can have x squared over a squared plus y squared over b squared is equal to 1. And the focal axis, A is the big number. Okay, so notice, A is underneath x squared here, so my focal axis is my x-axis. What's the alternative? The alternative would be y squared over a squared is equal to, sorry, not equal to, plus y squared over a squared plus x squared over b squared is equal to 1 would mean that my bigger number, a is the big number, bigger number is under y, so this would mean the y-axis would be the focal axis. Let's look at this x-axis situation though. It's going to look like this, right? Major axis is on the x. So think about this for a second. If my center is at 0, 0, which this tells me that it is, because my alternative would be to have the hk, my foci would be, if my center is at 0, 0, and up here I showed you that the focus is distance c, so my foci would be plus or minus c comma 0, because they would be from the center 0, 0 out the distance c and out the distance c from there. Vertices, they are the distance a from the center, so those are going to be plus or minus a comma 0. The semi-major axis, well, if you think about the focal axis or the major axis, semi-major axis is going to be equal to A, meaning that's halfway of the major axis. The semi-minor axis is going to be B, right? Because the minor axis is the short one, and that's this distance B here. So the Pythagorean theorem, as it applies to this, is A squared is equal to B squared plus C squared. That is for this ellipse situation. So why is that going to help us? Well, they're going to give us different information. They might give us where the focus is. They might give us what the semi-minor axis is. That's going to give us those distances. Let's think about the foci for a minute here. If I've got an ellipse that goes up and down this way, right, and it has a center at 0, 0, my foci are going to be from the center up and down the distance c. Well, they would go in this y slot here. So my vertices are going to be a distance a, right? A, and so it's going to be 0 and plus or minus a. My semi-major axis is still going to be a. My semi-minor axis is still going to be b. My Pythagorean theorem still applies. A squared equals b squared plus c squared. So what are my alternatives here? Well, I started out, A is the big number, right? Always the major axis, always that focal axis. And so what happens if x comes first and it is over A squared, but I'm moving, what's going on here? I'm moving my center. Well, it would look like this. Y minus k squared over b squared equals 1. Still equal to 1. Well, what's my focal axis? In this case, it's still going to be my x-axis, right? But I've got to move it. So if my x-axis is here, right? So then I've got to move it. It's going to be y is equal to k. Think about it like this. If my 0, 0 is down here, and this is my focal axis, right? Where did it move? Well, this distance here is k because my center is at h comma k. So if my center is at h comma k, wherever I move my axis, I move it up that same amount. Where are my foci? Well, my foci are still at 0 comma plus or minus c. And my vertices are still at, that should be the other way around. Wait a minute. So let's look at where my foci are. Well, if I've moved, so I've got my major axis on X, and I've moved this around. Let's just think about this for a second. Before, my major axis had plus or minus C. Well, my H coordinate has affected this because it's moved left and right, H, correct? So let's say we've got this ellipse, and I move it to the right 3. Well, out from that center is still going to be the C distance, but it's going to be H plus or minus C, and then comma K is going to be my Y coordinate. My vertices are going to be H plus or minus A because it's going to be moved to that HK, and then out from the center, the distance A, comma K. And my semi-major axis is still A, my semi-minor axis is still B, and this is all still the same. Let's look at what it would be like if we had an up and down. So vertically stretched, so my focal axis is vertical now. That would mean that my A value is underneath my Y, which is fine, plus X minus H squared over B squared is equal to 1, still equal to 1. What's my focal axis? Well, my focal axis is going to be an X equals number, right? Because the focal axis is going to be an up and down line, so it's going to be X equals H. My foci are going to be along that X equals H line, but they're going to be out a distance C. So what does that mean? Well, that means that I'm going to have H, so move it left and right, and then from there, there's going to be K is my center, but I moved it out from that center a certain distance, and that distance is C. So K plus or minus C. Same thing works for my vertices. So I've got this ellipse here, and hopefully you can see this. Hopefully I'm not off the screen. I've got this ellipse here, and my center is at HK. If I move out A, that would mean I've got K, and I move up or down the distance A. Semi-major axis, semi-minor axis. A squared is equal to B squared plus C squared. I didn't mean to go through that too quickly, but as we can see it with logic and we can see these pictures, it's going to become clear exactly what's going on here. Let's work a couple of problems. You've got to be able to use these pieces effectively. It can help to draw a picture. Make sure your equation is set, and maybe draw a picture if you're having trouble visualizing where these distances are. So it wants to find the vertices and the foci of the ellipse 4x squared plus 9y squared equals 36. Check out your equation. What's it need to be equal to? Well, it needs to be equal to 1. So what I'm going to do is take this equation, I'm going to divide both sides by 36. What I'm left with is 4x squared over 36 plus 9y squared over 36 is equal to 1. I got to reduce this. X squared over 9 plus y squared over 9 divided by 36 would be 1/4 is equal to 1. It can help you to rewrite this in terms of an a squared. So this means x squared over 3 squared is equal to y squared over 2 squared equals 1. I keep doing this. It's not equal to. It's actually a plus. So what does this mean? Look for the bigger value. That's a. So this is a squared. So that means a is equal to 3. The smaller value is b, so that means b is equal to 2. Well, I need to find c. Why do I need to find c? Well, it wants me to find the foci, and I know from up here that my focus is c distance. This should be a c, looks like a d. C distance from my center. Well, what's my center? My center is at 0, 0 on this one. And so I need my c value. So a squared is equal to b squared plus c squared, which means 9 is equal to 4 plus c squared. So c is equal to square root of 5. Okay, so c is equal to square root of 5 in this case. So that means my vertices, and take a look at this. If my big number is 3, right, 3 squared, is underneath my x, that means this, right? That means it's an x-axis. centered at 0, 0. And if my A value is 3, that puts my vertices at 3, 0 and negative 3, 0 because A is 3, which puts my vertices and my foci in this relationship. This is the distance C here. So this is root 5, and this is root 5. And so my vertices are at plus or minus 3, comma 0. And my foci are at plus or minus square root 5, comma 0. Set my equation equal to 1, found my A and B values, found C, plugged it in. All right, let's take a look at this next one. Find an equation for the ellipse with a foci at 0, negative 3, and 0, 3. I'm just going to draw a picture. So 0, negative 3, here. So it looks like this. So those are my foci. Well, what do I know about foci? Foci, this is distance C, so C is equal to 3. The minor axis has a length of 4, so this is 2. Well, the minor axis tells me B, so that's B is equal to 2. How do I know? That's 4 over 2, because my minor axis, this in total is 4, so that means B is equal to 2. Sketch the ellipse, support your answer, support your sketch with the grapher. So this is 2. Well, what does that mean for my vertices? Well, I want to find the equation. So let's just take a look. Is it an x equals or a y equals? If it's up and down, it's going to be where y is over the larger value. So I've got y squared. Well, and is it moved around my center? If my foci are equidistant from 0, then I know that it's not. So y squared over a squared plus x squared over b squared is equal to 1. How did I know it was y first? Well, it's up and down, because obviously my foci are on this up and down line. And so I've got y squared over, I don't know what a is yet, but I do know what b is, because b is my minor axis. So I've got plus x squared over 4, because b squared would be 4, is equal to 1. Why do I need this c? That's going to help me. I'm going to use my Pythagorean relationship. So if a squared is equal to b squared plus c squared, a squared is equal to 4 plus 9. That means a squared is equal to 13. So a is equal to square root 13. And so on the bottom here goes 13, because that would be a squared. Boom. Done.
Will the following students...
All right, let's look at one more. Standard form of the equation for the ellipse whose major axis has endpoints. These are the vertices, endpoints of the major axis. And whose minor axis length has a length of 8. So let's take a look. I'm actually going to sketch this. So negative 2, negative 1. And 8, 1, 2, 3, 4, 5, 6, 7, 8, negative 1. So this is, oh, and my minor axis has a length of 8, which means that b is equal to 4. So this is going to be at 1, 2, 3, 4. 1, 2, 3, 4. That minor axis length is measured halfway, right? So halfway between negative 2 and 8. So halfway between negative 2 and 8 is going to be 5, because that's a total of 10. So it's going to be 3 comma negative 1. So 1, 2, 3, negative 1. Here's my center. If my minor axis is 4, I need to go up 1, 2, 3, 4. 1, 2, 3, 4 down, and my ellipse looks kind of lumpy, but like this. Well, what does that mean? That means that this is 5. So my distance here is 5. I got that from halfway between my endpoints. So that means that A is equal to 5. My B is equal to 4, because that's half of my minor axis. And so C can be solved like this. A squared equals B squared plus C squared. So 25 is equal to 16 plus C squared. So that means 9 is equal to c squared, so c is equal to 3. What does that do for me? Did I even need that? I probably didn't even need that. But I know where my center is now. My center is at 3, -1. And so, if my A is 5 and my B is 4, and my major axis goes this way, I lead with my biggest number. My A is 5, so this is 25, and it's x minus 3 squared, plus y plus 1 squared over, and I need my B value, 16 is equal to 1.
Will the following students please